So now we're given a figure with the sun up here and it's casting a shadow, and of course as the sun moves the shadow length will change. We're asked to, so this is an 80-foot building, we're asked at what rate is the shadow decreasing when we're given that the angle between the ground and the sun is increasing at a rate of 0.0015 pi radians per minute. So of course as this angle is getting bigger, that's telling us that the sun is moving up in, where'd my cursor go? Sorry, it's moving up in this direction, right? And so this angle is going to get bigger. Okay, so notice that the shadow length is one of the variables changing, so I'm going to label that with an S, and so now we see we have the opposite and the adjacent side. So we have the tangent of theta is 80 over S, or tangent of theta equals 80s to the negative 1 for the sake of taking derivatives. So we take the derivative of both sides with respect to t, so we get secant squared theta times d theta dt equals negative 80s to the negative 2 negative squared times ds dt. Now we need to plug in all the known values, but we don't know what theta is, so we have to first figure that out. So we solve the equation tangent of theta equals 80 over 60, because we're stopping at the moment when the shadow length is 60, and solving for that we get 0.92729. So we substitute all our values into our equation, and in this case we're actually solving for ds dt. So when we simplify both sides of the equation, you can see what we get here, and now we solve for ds dt by multiplying both sides by negative 45. And we get negative 0.589 feet per minute. It should make sense that this shadow length is decreasing since the angle is increasing.